we look at some examples, let's just talk about this quick, because this came up in some sections. So, this is an XY coordinate system, okay? Now let's say that we have a guy standing on the XY coordinate system. Right. And let me just give you some markers here. Alright, so let's say that we want this guy to end up here. Okay? So he's only allowed to walk on the x-axis or the y-axis. So, and he has to walk on the x-axis before he walks on the y-axis. So, to get here, what would you tell him to do?
Jump.
No, he has to stay on the x and the y. Not on the axis, but he can only walk in the x and the y direction. So Josh, you're going to tell him first walk how many in the x? 4, right? So go over 4 in the x, that's going to put him here. And then go how many in the y, Josh? 3. And if you do that, you will end up here.
There's a ladder.
Okay? So he went 4 and 3. And that got him where he needed to be. Now if I take away that limitation and I say, okay, you can walk any way you want, and I want you to take the shortest path there, he would just do that. Right? Straight line. And then if I called out to him and I said, hey, what is your x component? What would he say? Josh? 4. Right? He's over 4 on the x. If I said, what is your y component? He would say 3. Okay, and that's what we've been doing with these vectors. We have an x component of 4 and a y component of 3. Now, if instead I didn't want him to end up there, and let's say I wanted him to end up right here, put him here. And I said, hey, I want you to go here. And so he went there. And then I called out to him and I said, hey, what is your x component? 5. What is your y component? 0. Okay. Does everybody get that? So when we're looking at vectors, you know, if it falls on one of the axes, in other words, if it's completely horizontal or vertical, then the other component is 0. Some people weren't sure of that. Okay. So now I think yesterday we did the